Myself, Dr. Prashant Kumar Bardhan, Professor, Department of Mechanical Engineering, GIS College of Engineering, Kolani. My subject topic is Advanced Welding Technology, ME 703A. Course objective: after completion of this course, all students will meet the following objectives: to impart knowledge on various advanced welding processes so that the students can apply them in engineering industry applications; to develop the knowledge on the design of weld joints and the quality control of weldments. Course outcome: upon completion of this course, the student will be able to achieve deeper knowledge of welding materials and technology of welding, deeper knowledge of different metals and their properties in welded construction, knowledge of quality technique and production by welding, knowledge of current computer robotic systems and cost of welding operations. Advanced Welding Technology, ME 703A. There are 7 modules. Module 1, Introduction, Review of Welding Processes and Welding Joints, Joint Design. Number 2, Module 2, Process of Fusion Welding, Arc Welding, Submerged Arc Welding, Gas Metal Arc Welding, Sealed Metal Arc Welding. Module 3, Solid State Welding Process, Pressure Welding. Module 4, Friction Welding, Electron Beam Welding, Ultrasonic Welding. Module 5, Gas Tungsten Arc Welding, Plasma Arc Welding, Welding Equipments, Electrode Selections. Module 6, Welding Metallurgy, HAS, Weldability of plain carbon steel, stainless steel, cast iron, aluminum. Module 7, Welding Defects, Type, Causes, Inspection, Remedial Measures, Testing of welded joints by visual, type penetration test, radiographic test, ultrasonography, safe practices, safe welding. Prerequisites: manufacturing technology, welding technology, joining of metals. This is the COPO mapping, 4 COs against 12 POs. This is the points. C is the maximum points, 1 is the minimum points. So this is average figure, COs against this, POs against these COs. Advanced Welding Technology, ME 703A, Weldability of Stainless Steel, by myself, Dr. Prashant Kumar Bardhan, Professor, Department of Mechanical Engineering, GIS College of Engineering, Kolani. Weldability of stainless steel. There are 5 types such as stainless steel, austenitic stainless steel, ferritic stainless steel, Martin stainless steel, duplex stainless steel, precipitation hardening stainless steel. These are the 5 types of stainless steel. Most commonly is the austenitic stainless steel. AWS specification of weldability: the capacity of a material to be welded under fabrication conditions imposed into a specific, suitably designed structure and to perform satisfactorily in the intended surface. Weldability of austenitic stainless steel. It has the following compositions: carbon 0.03 to 0.025% silicon 1 to 2, nickel 3.5 to 22%, molybdenum and titanium in some cases, manganese 2 to 5%, 10% is not 10, 2 to 5%, chromium 16 to 26%, phosphorus and sulfur 0.04, 0.08, aluminum and titanium. Equivalence. They possess a high corrosion resistance of all the stainless steels. They possess a great strength and ductility and non-magnetic and so on. Application in the aircraft industry, austenitic process plant, cryogenics, medium corrosive applications used over wide temperature ranges. Chemical processing, heat exchanger, dairy industries, milk cans, etc. is manufactured with the aluminum austenitic stainless steel. Say it is called austenitic stainless steel is 304, 308 series AISI 304 or 308 or 316 with molybdenum. These are the austenitic stainless steel. This is the stainless steel AISI 304. AISI means the American Iron and Steel Industries. 304 is the grade is called austenitic stainless steel. This is the milk can produce with austenitic stainless steel. Welding techniques: oxy-acetylene welding, arc welding, sealed metal arc welding, gas tungsten arc welding, submerged arc welding, plasma arc welding, resistance welding, flash spark welding, projection welding, seam welding, spot welding, percussion welding, and also brazing. Welding procedures: thermal conductivity is low, about 50%. Melting point is low. Thermal expansion is about 50% lower. Electrical resistance is about 6 times greater. The first 4 factors combined required for low welding current. So austenitic stabilizer is a nickel equivalent. Carbon, nickel, nitrogen, manganese, copper. And ferrite stabilizers, that is chromium equivalent, chromium, molybdenum, vanadium, tungsten, niobium, silicon. Problem associated with austenitic stainless steel: ferrite and sigma phase formation, carbide precipitation, stress corrosion crack, ferrite and sigma phase formations. This problem is corrected by that electrode that deposits weld metals containing 3 to 5% of ferrite. Sigma phase can be dissolved by heating above 900 degrees centigrade Celsius for short time. Carbide precipitation, thermal treatment 845 to 425 with fast cooling, use of low carbon stainless steel, that is 0.08 or 0.04, 0.03, stabilizer chromium, niobium, titanium, tantalum, columbium, stress corrosion cracking, annealing treatment, remove chloride and oxygen. Weldability of ferritic stainless steel. It has the following compositions: carbon 0.08 to 1.5, manganese 1.1 to 2, sulfur 0.04, silicon 1%, chromium 11 to 27, phosphorus 0.04. They possesses magnetic and good ductility. It is more corrosion resistance than multi-static stainless steel. Application: lining, petroleum industry, heating elements for furnace, screw and fittings. Ferritic stainless steel sensitive to grain growth, loss of toughness, embrittlement, limited to 250 degrees centigrade service temperature, can lead to cracking in weld or has for highly restrained joints and thick section material. Hydrogen cracking, filler metals, matching austenitic and nickel alloy. Welding techniques: gas metal arc welding, submerged arc welding, gas tungsten arc welding, sealed metal arc welding, resistance welding, flash spark welding, projection welding, seam welding, spot welding, percussion welding. Welding quality of ferritic stainless steel is poorest of AISI types. Welding heat a zone in the base metal above critical temperature 955 and cause rapid grain growth of ferrite. Excess grain growth avoided by lower heat inputs. Adding of aluminum, vanadium, zirconium to suppress the grain growth during welding. Intergranular corrosions avoided by annealing 650 to 800 degrees centigrade, about 10 minutes to 60 minutes. Preheating 150 degree or higher to minimize the residual stress. Thin section is not required. Thick section required for preheating. Post-weld heat treatment reduce hardness and residual stress. Weldability of martensitic stainless steel. It has following compositions: carbon 0.15 to 1.2, manganese 3.5, ferrous balance, silicon 1.8, chromium 11 to 18%, nickel 1.25. They possess the hardness and ductility and magnetic and so on. It is best thermal conductivity of stainless steel. It uses martensitic stainless steel, pump and valves, surgical instruments, rules, and tape. Weldability of duplex stainless steel. Duplex stainless steel are called duplex because they have a two-phase microstructure consist of plain of ferritic and austenitic stainless steel. Higher strength than either ferritic or austenitic stainless steel. Greater corrosion resistance, particularly stress corrosion, cracking, 15 to 30% chromium, up to 5% molybdenum, small amount of nickel. S3 series of stainless steel, magnetic application vessel vessels, storage tanks, structural applications, that is beach. This is a 3 duplex stainless steel, lean duplex. This is standard duplex. And another duplex is there. Weldability of precipitation hardening stainless steel. These steels can develop very strength, high strength, and adding elements such as copper, niobium, aluminum to steel. With a suitable aging heat treatment, very fine particles form in the matrix of steel, which imparts strength. It is a non-magnetic, good corrosion resistance, high toughness and strength, provide an optimum combination of the properties of martensitic and austenitic grades. Weldability of precipitation hardening. It is called 17.4 pH stainless steel. Application: aircraft parts, shaft, spindle, pump. Example: the most popular precipitation hardening steel is 17.4 pH. The name comes from the addition of 70% chromium and 4% nickel. It also contains 4% copper and 0.3% niobium. 17.4 pH is also known as the stainless steel grade 630, which transforms to martensitic at low temperatures, typically around 250 degrees centigrade, and are further strengthened by aging at between 480 to 620 degrees centigrade. Welding technique: sealed metal arc welding, gas metal arc welding, gas tungsten arc welding, submerged arc welding, spot welding, flash welding, friction welding, and electron beam welding. Welding problems: hydrogen cracking, normally matching consumers, high hardness in the hash heat evacuation zone makes this type of stainless steel very prone to hydrogen cracking. The risk of cracking increases with the carbon content. Above carbon 0.15 to 3% not suitable for welding. Underbeat crack. Take precautions to minimize preheating and post-weld heat treatment. Sensitization. Sensitization refers to the precipitation of carbides at gate boundaries in a stainless steel or alloy, causing the alloy to be susceptible to intergranular corrosion. This results is susceptibility to intergranular corrosions. Austenitic stainless steel may become sensitized if they are heat treated or used at temperature in range of 500 to 800 degrees centigrade. The heat affected zone of welds may also be sensitized in some circumstances. Intergranular corrosions, this is the intergranular corrosions. The grain boundaries, chromium carbide formations, this is chromium carbide, black one, chromium carbide zone. This is the interboundaries, this is the chromium carbide, these are the chromium carbides. Intergranular. Chromium depleted zone causes more amount of carbon content, slow rate of cooling from 425 to 845 degrees centigrade. So it is also called sensitizing temperature range. Time, temperature, chemical composition play a vital role in sensitization. Preventions. Fast cooling requires because the carbon does not react with the chromium. Stabilizer, columbium, niobium, titanium, tantalum. Both base material and fill rod have low carbon content. Sigma embrittlement. Sigma phase is a non-magnetic compost mainly of iron and chromium, which forms in ferritic and austenitic stainless steel during exposure at 560 degree to 980 degree centigrade. Many stainless steel and other iron chromium alloy are susceptible grain boundary phenomena known as sigma phase embrittlement. Alloy elements such as molybdenum, titanium, and silicon promote the formation of sigma phase. Molybdenum promotes sigma phase formation much more effectively than chromium, particularly at temperatures around 900 degrees centigrade. This is sigma embrittlement. A, this is embrittlement is a crack. This is embrittlement crack. A, B, C, D. Four samples are there. How the crack occurs. Big cracks and small cracks. There is also hair cracks. Causes loss of ductility and toughness, corrosion resistance resulting in cracking, failure components, especially those subject to impact load or excessive stress. Prevention, nitrogen and carbon reduced as it tendency to form. Annealing treatment. Mode of solidification. Solidification, also known as freezing, is a phase change of matter that results in the production of a solid. Generally, this occurs when the temperature of liquid is lowered below freezing point. There are four modes: planar, cellular, columnar dendrite, and equiaxial dendrite. This is a growth rate. This is a cooling rate, growth rate, R, and temperature gradient G. This is a coarse skin structure, low cooling rate. This is low cooling rate. This is a high cooling rate. This is high cooling rate. This is the planar, cellular, columnar, and equiax dendrite. These are four phases. Fine grained structure. So planar, cellular, columnar dendrite, and equiaxis dendrite. This is the dendrite. These are the dendrite grain boundaries. This is the unit. This is some carbide formations, precipitation. This is porosity. This is porosity. This is cellular and columnar dendrite. This is a columnar dendrite. This is columnar dendrite. Phase front single phase, and this is cellular phase. Cellular plane front two phases. Two phases. This is columnar and this is cellular. This is another type, planar. This is called, this is planar type. Phase, just change your phases. So welding metallurgy or this stainless steel, weldability of stainless steel, this is today's session end. Thank you.